Good day, everybody. Welcome to Skyway's live webinar, Highway in the Sky, Route Management for UAM Airspace Success. My name is Beau Cassidy. I'm with Business Development for Skyway. Just to get into a little bit about what Skyway is, Skyway is a provider of services for UAM, a PSU, that issues low altitude airspace authorization. Our system enables UTM, eVTOL, and UA operations to share airspace intelligence with ground operations such as vertiports and air traffic control agencies. Skyway integrates various airspace services into one cohesive infrastructure solution, one that provides real dynamic flight planning for piloted and autonomous aircraft. At Skyway, we do a great deal of research, of internal research on a variety of topics with our experts and our partners, with our core business being traffic management for UAS and eVTOL. So it'll be really exciting to delve into this topic into detail today. Our primary goal is to build an ecosystem that allows UAM to grow extensively. We will be having a short Q&A after the presentation. However, you are more than welcome to submit your questions at any time. So allow me to introduce to you guys Senior Geospatial Engineer Cory Martin. Cory, good to see you, and I would love to hear a little bit about your background today.
All right. Thank you, Beau. Well, my name is Cory Martin. I'm a pilot. I learned to fly in the early 90s in the Midwest of the United States, especially in Chicago, which is some of the most complicated and dangerous airspace in the country. I am a professional geographer and entrepreneur and software engineer. I've founded several companies, and I have joined and transformed others. Maponics being my most successful operation, and I've informed everything from U.S. healthcare policy to powering Google Maps and Realtor.com. I sold Maponics to Pitney Bowes a few years ago, and that company is now Precisely. I also founded the Weekblad service in the Netherlands, and that is now houseonhouse.nu. I've been an amateur roboticist and electronics enthusiast for all my life. My dad worked for Apple and was a ham radio enthusiast. So I learned to build a lot of electronic systems and even built my own radio-controlled aircraft and even autopiloted aircraft. I am multilingual. I speak English, Nederlands, Dutch, Espanol, Spanish, and I am based in the Dallas-Fort Worth Metroplex. You can probably tell by the hat that I'm a Texan.
Great, thanks, Cory. And just to give you an overview of what we're going to be discussing today, we're going to get into the challenges that air traffic management faces with the UAM industry as a whole, the FAA's role and involvement in how this industry grows, UAM and UTM's role in airspace management, the transition, the evolution of autonomous flight, where we are now and how we're going to be able to get there, and the core UAS air traffic control system. So just to get us started, why don't you explain to everybody sort of some of the challenges that aspiring air traffic managers are facing at the moment?
Certainly. Well, I have a good friend, Bud DeBolt. He's the air traffic manager with the Dallas-Fort Worth TRACON. He shared with me that unmanned systems were the bane of air traffic controllers' existence. He needed something. They were looking for anything that could reduce the burden because they just weren't ready at that time when unmanned systems came out. So we have to realize that today's air traffic management systems were created in the middle of the 20th century for 20th century problems. They focused on the fixed wing commercial flights. They really didn't have a vision for unmanned systems. So when the FAA started their next gen process in the United States, they began this ongoing process that taking several years. It may take a couple of decades. They are modernizing the air traffic management system with new technology and new procedures. Where they had previously focused on the human piloted flight, they are finally bringing unmanned flight into the fold with UTM and UAM concepts of operation documents, which are guiding where we're going to go with UAM and UTM traffic management. So the FAA responded to the sudden growth of all of these drone aircraft, these small UASs that weighed 55 pounds or less, and were up. And they decided that they would restrict most drone operations to 400 feet and below above ground level. They were looking for a way that they could provide some beyond visual line of sight capability, but that still requires a waiver. But they were making this system and they were starting to regulate it. They required a remote pilot license. They still allowed you to fly uncertified aircraft, but the weight limit and the size limit on this really restricted operations to just a few basic services. You couldn't really carry passengers because of the 55-pound weight limit, and you certainly couldn't carry very heavy parcels. So in conjunction with the industry and with NASA, FAA started talking and looking at how they could apply existing rules like Part 135 and adapt that to unmanned flight, especially for urban air mobility and advanced air mobility purposes. So they've repurposed Part 135, which was created to certify air carriers and air taxi operations in the United States. It requires a qualified commercial pilot. The aircraft have to be certified for their airworthiness, but it opened up the national airspace system, the 500 feet and above, to larger unmanned aircraft. And by removing the size and weight limit and by making it in the hands of a qualified commercial pilot, they would authorize beyond visual line of sight operations that could carry passengers or heavier packages. Some of the operators certified now under Part 135 are Amazon, Wing, and Flight Forward from UPS. So as I was saying, the first 400 feet above ground level was really carved out for the UTM aircraft, the aircraft that are under 55 pounds, that aren't carrying very heavy packages. They're doing missions like aerial photography, cinematography. They're doing agricultural spraying and whatnot. Above 400 feet, they started establishing corridors, or they envisioned corridors that might be at 1,500 feet up to 3,000 feet or so forth, to allow the larger unmanned aircraft that are carrying larger packages, that are carrying passengers. Now, they're going to have to transition through everybody's airspace. I mean, the big planes, the helicopters, everything are still going to have to land at facilities on the ground. The UAM aircraft are going to have to transition through possibly very congested airspace with drones up to their corridors and whatnot. But this is an idea of segmenting the airspace, creating room for everybody to operate safely. So there have been two traffic management solutions. We have aircraft flying at all sorts of altitudes. We have the traditional aircraft, including unmanned aircraft, that are operating at 18,000 feet and above. We have urban air mobility, surveillance, and other general aviation stuff operating between 400 feet and 18,000 feet. And that 400 foot and below level is being managed by UTM systems that are focused on those small UASs operating below 400 feet. Now, air traffic services aren't being provided below 400 feet from the FAA, but there will be some services provided through PSU partners and so forth for unmanned systems operating in the national airspace.
And before you get into PSUs, you brought up the UTMs. Can you just describe and outline what their purpose is and how they fit into the ecosystem specifically?
Certainly. Well, there are quite a few UTM market leaders right now. These are a few of them. UTMs are focusing on those small unmanned systems there that are operating below 400 feet, except where they need to go above 400 feet for tower inspections and so forth. The FAA isn't providing any air traffic control services for these small UASs, and they're requiring that you go through these UTMs to get authorization to operate near an airport. They use this LANCE capability, the low altitude authorization and notification capability, to inform the tower and get permission from the tower to operate near airports so that it doesn't interfere with traditional operations. The FAA is also authorizing the establishment of authorized areas of operation through certificates of authorization and whatnot to allow more frequent flights near airports, especially major airports. It happens here between Dallas Fort Worth Airport and Love Field. And in this example, we have at Fort Wayne International, the controllers have established with the UAS operators 2 areas of operation. One of them is outside, far enough away from the airport that it can operate more or less continuously. Of course, the FAA can deactivate an area for an emergency or for any reason whatsoever, really. But it's informing pilots and other airspace users that there will be drone operations in that area on a quite frequent basis and to be on the lookout for them. Now, within that 3 nautical mile ring that is so close to that airport, those runways, they've established a smaller area of operations that then will turn off if the wind changes and they start using the northwest southeast runway. But for the most part, that area of operations will be open to drones and other UAS aircraft so that they can operate safely near an airport.
You bring up all of these different UTMs as you showed on that previous slide. And then also in consideration of the fact that you're going to have larger payload unmanned drones, you're going to have passenger VTOLs. It's an interesting question. How is all of this data going to be aggregated to provide the proper routes when you have so many different facets siloed in the industry?
That's right. So the provider of services for UAM, the PSU, which Skyway is one of these, we're taking data from a whole bunch of agencies, from the FAA, from other providers of UTM and services to UAS, and from the secondary data service providers. We're taking this, we're analyzing it, we're crunching it, we're using it to create a safe airspace with routing and optimized traffic flows that will enable us to really see UAM become ubiquitous, available everywhere and safely. So we have to do a lot of communication and cooperation with other PSUs, with the providers of UTM traffic management, with the FAA and so forth. Our goal is to minimize the burden on the FAA and their air traffic controllers and make it so that our industry can thrive. So the FAA, in its first go at this concept of operations on how things would work, placed the provider of services for UAM, the PSUs like Skyway, at the center of this ecosystem that would connect UAM operators with the FAA, with UAS service suppliers, with data suppliers like True Weather, our weather partner, and with others who might provide terrain and obstacle data. The PSU is taking all of this, they're understanding where the UAM operators want to fly, and we are telling the UAM operators where they can fly, how they can go about conducting their mission safely, getting their passengers or packages or whatever to their destination on time, reliably, without encountering problems. And we coordinate a lot with public agencies beyond the FAA, like with public safety, to be able to respond to emergencies so that we can. There will be, for example, air ambulances that will be autonomous. There will be police drones that need to be dispatched to an event, perhaps for fire services as well. We'll make sure that our managed traffic stays out of their way and that they get the priority routing and everything to their destination so that the public is well served. Basically, we're just keeping everybody working together very happily. And so PSUs and the UAS traffic management people have to work very closely together. The UAS service suppliers, they're focusing on the smaller 55-pound drones operating under 400 feet. They're providing traffic management for those aircraft, whereas the providers of services to UAM are focused on that traffic operating at the higher level, of course, aware of what's going on in the UTM space. We're operating in different airspaces. We're providing very similar services, but what we're doing is coordinating so that we're taking the information about what's happening at vertiports. We're keeping aircraft separated horizontally and vertically, and we're providing a scheduling and routing so that nobody comes in conflict with each other, so that we can really maximize the use of the airspace, especially in congested urban areas.
Yeah, so you talk about how the PSU sort of sits at the center of how this industry is going to work from a safety component, but I wonder the FAA's involvement in how this all plays out. You say that they're not going to handle some of the traffic. Why is that? What is their role in this whole thing, and how are PSUs going to communicate with the FAA?
All right. Well, the FAA has really focused on operations within the national airspace system with their traditional role of providing a safe and secure national airspace which passenger and cargo traffic can flow through. So they're focusing on their traditional mission with those larger aircraft. They are delegating the UTM and UAM air traffic management to the industry, to PSUs, to the USSs. They are involved in establishing safe areas of operation, especially around their airports and corridors where they would be concerned with. And so they need access to real-time operational data from both the UAM and UTM spaces. The FAA, of course, can open or close these UTM corridors and these UAS areas of operation, especially if they're responding to some off-nominal operation like an aircraft off course or an emergency. But for the most part, the FAA wants to stay focused on their traditional mission and let the industry come up with a management system that works well for it.
Yeah, and this all kind of paints the picture of where we're going to go from an autonomous standpoint, right? Obviously, we're at a very early stage in this whole process, but if you could kind of get into how we get there and what that process is going to look like from where we are now.
So this is going to be a multi-year process. We know that it's not economical to have a pilot piloting a small aircraft with 1 or 3 passengers on board. But that's how it's beginning out. It's we're still at a stage where we have very limited autopilot for most things. For package drones and larger package delivery UAS, we have uh, more autopilot with a remote pilot in command. That has, so there's some increasing assistance from autopilot, but where we need to be and where we will get to probably by the end of the decade is a fully autonomous UAM and UAS a system where the PSUs and the UTMs and everybody are working together to supply and feed the AI on board those aircraft so that they can safely navigate through a busier and busier airspace. So right now, we're at the point where the FAA has allowed the UAM community to drive the regulations, and the community has been able to establish most of the rules. Right now, with the current concept of operations for UAM, humans are very heavily involved in the loop. They're either in the aircraft or they're sitting remotely and managing 1, perhaps 2 aircraft. But as the technology evolves, as the procedures evolve, as we get better at this and reach a mature state, we're going to have aircraft that are capable of flying themselves more or less completely by themselves, with a human, of course, supervising. But a human will be able to supervise multiple aircraft, and that will make it most economical for UAM to operate. Now that's going to take a few years, but we're increasing that tempo all the time, and we're making leaps and bounds in that.
Yeah, it seems like the only way that this industry can scale is if it becomes autonomous, right? Because you don't have enough pilots, licensed pilots, to make all of these operations possible. So it's an interesting point. I'd love to hear you talk about the PSU as this new concept in UAM, but since it's so new, I'd love to hear you detail what it does and how it functions on a sort of a micro level.
All right. So a PSU provides quite a number of services. We're taking weather data in from our partner like True Weather, and we're taking information from the FAA, including notice to airmen and temporary flight restrictions that are established. We're taking operational data in from the UAS service suppliers and from the FAA and from other PSUs. And we're crunching all this, and we're helping plan flights so that they don't conflict with each other, so that they are operating safely, staying away from obstacles and from each other. We're ensuring that aircraft are compliant with standards, and that they are performing systems checks, especially for battery life and charge levels. We are the ones, the PSUs are the ones authorizing. They're taking the intent, the declared intent from the operators, and turning that into an actual plan and getting the clearances and everything that they need to fly. And we're providing the emergency awareness and incident management services that are going to keep UAM operating safely and get even safer as more and more aircraft come online. Of course, nothing at all is allowed to fly without checking and rechecking the weather. With UAM and UAS flight operating in an urban area, we need even more localized conditions and forecasts for those to operate safely. Today's weather reports have been focused on airports and conditions at airports, but we need to know the conditions downtown in the middle of a group of buildings. We need to know things so that our aircraft can actually get to their destination without encountering problems uh, like icing that would affect many rotorcraft. In fact, most rotorcraft will probably not be able to operate in icing conditions. Very few helicopters today are able to do that. But there are some fixed wing and some tilt rotors aircraft that may be able to fly in some of these more adverse conditions like icing. But weather is important for the flight planning, and additionally in flight planning, we're needing to make sure that there is ample space available at their destination, that there's a spot available to land. Quite a few of these facilities are going to be small and only be able to accommodate a couple of aircraft at a time. If the pads are full and we have an aircraft that is rapidly running out of battery and needing to land, that's not an ideal situation. And of course, we're still avoiding those adverse conditions, and we're working on reducing conflict to get these electric aircraft to where they need to be quickly and without running out of charge. We're going to keep them out of the areas that are dangerous and prohibited to them. And we're going to assist, especially as it becomes more automated, we're going to assist the automated pilot, especially with being able to land in an emergency situation, either divert it to another facility that is close by that it can reach, or at least to be able to come down in a way that minimizes injury and property damage. So we're doing a lot of things. It's very difficult with all of these new battery technologies and electric motor technologies. Whereas we had a pretty good idea of how fuel powered flight worked and fuel consumption and everything like that. It's going to be even more important for us to understand those the energy use, the electric consumption from batteries and the battery life and everything to make autonomous and UAM flight safe and ubiquitous. So we have to evaluate so much that's going on. There's a lot of stuff going on in the airspace. We have aircraft taking off and landing at multiple locations. And not only do we have our UAM aircraft and the other UAS systems out there, we have traditional aviation and everything. So we have to predict where aircraft are moving, when they're going to be at a certain location at a certain time. Everything is focused on minimizing conflicts so that the pilot doesn't be put in a situation where he has to make an emergency maneuver to avoid a collision, or there is no controlled flight in terrain or anything like that. We have to know and work with the vertiport facilities to coordinate takeoff and landing times. And we're trying to move aircraft from one place to another that might have a very limited range, but still keep them outside of areas where air traffic controllers don't want those aircraft. The main service in route planning is that we're providing and traffic management, we're providing a way of four-dimensional airspace deconfliction. We are segmenting the airspace into usable volumes with entry and exit times so that no two aircraft are sharing the same space at the same time. And this is an example of what we're going to encounter. We're going to have aircraft that are flying from an Amazon or a UPS facility or something like that are operating in a hub and spoke fashion, and they're going to be crossing into the paths of drones and larger aircraft that might be doing inspection of infrastructure. might be crossing into places where they're doing flight training. Heck, there might be a place where they're doing skydiving operations and things like that. We need to be able to be aware of what's going on in all the different parts of the airspace so that we don't have an aircraft in the same volume of airspace as another at the same time. And 4D deconfliction looks like this. We either delay the entry of an aircraft into a volume segment, or we adjust the routing of that aircraft to go above or below the other aircraft. And that keeps aircraft from occupying the same space. It keeps them from colliding with one another and result in loss of life and injury. So we're really doing, as PSUs, all the work, so you really don't have to do that much. We're providing open APIs to allow all the stakeholders, whether the UAM operators or anybody else, other PSUs, anyone from across the industry, to be able to get the most informed routes possible. We're providing the micro weather in conjunction with our partners. We're assisting the vertiports with getting flights in and out and maximizing the utilization of those vertiports. We're doing the vehicle monitoring, and we're going to make this safe, scalable ecosystem that's only possible when a PSU is providing critical services. We're even going to provide emergency services, emergency awareness that's going to give the eVTOL operators the ability to make critical decisions and get their aircraft down safely. Most importantly, we're allowing businesses to realize the dream that UAM can provide at low cost. That is what a PSU like Skyway is doing.
Thank you so much, Cory. Wonderful work. As well as traffic management, Skyway offers experienced industry professionals to help plan your future investment in the future of eVTOL infrastructure and UAS infrastructure in general. A couple of the things that we are offering: UAM vertiport planning and simulation, something that we addressed on our previous webinar. Technical expertise, so DOT and FAA liaisoning, policy, regulatory consulting, vertiport zoning and ATM certification. We're going to be doing a webinar on that in the future as well. Resource allocation and assignment, and vertiport aircraft equipment integration. Now, speaking of integration, Skyway is actively looking for partnerships to integrate into the Skyway network. So UTMs, eVTOL operators, drone delivery services, supplemental data providers. Cory brought one up that is TrueWeather, our micro weather data provider. So we're looking for integrators for us to build the most informed data hub for UAM possible. So if you're looking to possibly partner to integrate, please contact me. My email is below here on the slide. It is beau@goskyway.com. Our next webinar is going to be on public safety in UAM. So making public safety a priority as this industry scales. Having PSUs enable the public safety use cases across the industry, like the police drones and the fire department drones, and maybe even an ambulance drone that Cory brought up earlier, the different vehicle types that are going to be used, and the UTM integration tool that will be vital to success to allow this industry to be open. Thank you for watching. We will now begin a Q&A portion of the presentation. If you have not submitted your questions, please do so now. Just a quick thing, you can follow us on social media. Please do so at the handles that are listed on the slide. Our website is goskyway.com. When taking a look at the LinkedIn, you type in Skyway, make sure that it's the Skyway page with our logo, because if you just type in Skyway and then click enter, it'll take you to a company that's not even named Skyway. Don't ask me why. So please do so if you haven't submitted your questions. We have a couple here if you're ready, Cory, to answer a few of these, if you don't mind.
Sure.
Okay, great. Around UTMs and PSUs, don't UTMs already handle route management? What's the difference between you and a UTM?
Okay, so UTMs do provide some services, especially LANCE, the low altitude notification thing around airports, where if you want to operate within a certain distance of an airport, you have to have permission from the tower, and that's obtained through a UTM. UTMs are focused on those smaller drones operating usually below 400 feet. They're not focusing right now, at least. They're not focused on anything that's happening outside of their thing, except they need to be aware of aircraft from the UAM space and from the general aviation and commercial aviation spaces that are going to be landing and taking off and transitioning through airspace that drones and so forth are operating in. So we work very closely together, and both models under the UTM and UAM concepts of operations both call for them to work together very closely to ensure that there are no conflicts between the different aircraft types in the airspace.
Okay, so here's one on timeline. How soon will your system be ready to be implemented?
Okay, so we're actually in Q2 and Q3 of this year. We are implementing our service in South Florida. So we are deploying that right now. We're working on the finishing touches and working on the integrations with our weather partners and everything in that region, so that we can deploy.
Okay. Here's one. How do you anticipate the dissemination of emergency info and time-sensitive restrictions? And what kind of all aircraft down measures do you think will need to be baked into the infrastructure?
That's a very good question. So emergency information is going to be disseminated in real time. So if there's an event, an incident of some sort, whether we receive it from a public safety agency or from the FAA or from an operator, anybody really, if there's an event that's an emergency, we're immediately putting into the plan the flight plans. We're holding flights from taking off, from entering airspace that's around these events, whatever. We're immediately putting a stop to that and diverting aircraft as needed, just like FAA air traffic controllers do today when there's an emergency. Now, with time sensitive restrictions, there are going to be all sorts of things. So there are going to be events that happen, whether it be a celebration with fireworks, that you can't fly over, things like Disney World during their fireworks and everything. There's like a permanent notice to airmen flight restriction around that, and so forth. And you can't fly, like here in Dallas, you're not allowed to fly over George W. Bush's house. There are things like that. There's going to be constant communication using the APIs and the protocols that the FAA and the industry have established, so that we can ensure that aircraft aren't going where they shouldn't be and get out of the way when some incident calls for them getting out of the way.
Great. Why would a UTM want to integrate with us?
Okay, so UTMs, we provide a lot of value to UTMs in that we are keeping track not just of what's happening in the UAM space, but we're also keeping track of what's happening in general aviation and with UAS. Everybody's sharing information with each other. We're pulling all this information in and information about their intent and how that mission is being carried out and so forth. We help UTM operators maximize the use of their dedicated airspace and and we depend on them to be able to help us transition between our UAM corridors and landing. So we have to stay in touch with each other. We have to work closely together, and we provide a lot of value, and that we can enhance a lot of the services they provide with greater information and the processing power we have. A total airspace awareness that
Great.
we provide.
Will there be more than one PSU in an airspace?
I think initially there will be. There will be a lot of number of players, just like we have in UTM right now, where we have a lot of different UTM apps and companies that are allowing authorization to operate near airports and to keep the aviation community aware of where they're operating and so forth. Anyway, there's going to be a lot happening, and if you repeat that question one more time, I can.
Yeah, no problem. Will there be more than one PSU?
Yes, there's going to be more than one PSU, just like is happening in UTM. But we're going to probably see, because of the technology and range of services and differences in those services, we'll probably see one or two become dominant in an area.
Got it. That makes sense. Okay, well, that includes our Q&A. Thank you guys so much. If your question was not asked, please feel free to reach out to Cory directly at Cory@goskyway.com. Again, my email is Beau, B-E-A-U, @goskyway.com if you're looking for possible integration with your company and you're looking for a more comprehensive data set with the UAM community. Please feel free to reach out to me. And with that, I bid adieu. Have a wonderful day, and we'll see you at the next webinar, everybody.
All right. Thank you.